Hello everyone, in this video we will be reviewing echelon form and reduced row echelon form. We will first start by reviewing what it means for a system to be in echelon form. A system is in echelon form if each leading variable is to the right of the leading variable in the row above it. Recall that the leading variable is the first variable with a non-zero coefficient in each row of a system. Now that we have reviewed our terminology, we will do an example. For this problem, we must get the system in echelon form. Our first goal is to make the x in the first row be the only x in the system. We can use row operations to do this. The three row operations we can use are swapping, multiplying by scalar, and row combination. First, let us eliminate 3x from the second row. To do this, we will multiply the first row by -3, then add that to row 2. Notice that the first and third row did not change. The only row that changed was row 2. This is because we only applied the row operation to the second row. You should also notice our notation to show the row operation. The P represents the word row, and the subscript after P is the row number. We still have an x in row 3. We will use row operations to eliminate it. We can multiply row 1 by -5 and add it to row 3. We have now cleared all the x from row 2 and 3. Notice that the leading variable of the second row is to the right of the leading variable in the row above it. We do not have to change row 2 now. Now we must work with row 3 to make the leading variable to the right of the leading variable of the row above it. We will multiply row 2 by -4 and add that to row 3. This system is now in echelon form. It is helpful to have the system in echelon form because we can solve for one variable, then use back substitution to solve for the rest of the variables. Once we do back substitution, we get that x equals 2, y equals 5, and z equals 7. Reduced row echelon form makes solving a system even easier. If a system is in reduced row echelon form, we can easily see the answer. Before we work on an example, we will review what it means for a system to be in reduced row echelon form. A system is in reduced row echelon form if, in addition to being in echelon form, each leading entry is a 1 and is the only non-zero entry in its column. Our system is already in echelon form, so we must now make each leading entry a 1 and make it the only non-zero entry in its column. We will start from the bottom and build our way up. First, we will make the leading entry in row 3 a 1. In order to do this, we will multiply row 3 by 1/5. Now we must make z in row 3 the only non-zero entry in its column. We will multiply row 3 by 2 and add that to row 2. We will now multiply row 3 by -1 and add that to row 1. Z is now the only non-zero entry in its column. We will now work with the y column. First, we must make the leading entry in row 2 a 1, so we will multiply row 2 by -1. We must now make the y in row 2 the only non-zero entry of its column. In order to do this, we will multiply row 2 by -1 and add it to row 1. Our system is now in reduced row echelon form. As you can see, it is easy to see that the solution is x equals 2, y equals 5, and z equals 7. Thank you for joining me in this review of echelon form and reduced row echelon form.